Hello, everyone. My name is Dahlia Bailgin,
And my name is Megan Wang.
and together we created Future Skyline, an organization aimed at solving environmental problems by combining creativity and chemistry.
I want you to imagine walking through a busy city, honking cars, crowded streets, and an air so thick with pollution you can almost taste it. That's the reality for millions living in urban areas today. But what if we could change that? In this presentation, we'll walk you through the problem we're tackling, introduce our solution, vapor, or vapor air purification on response, and end with the impact we hope to create. We will be tackling SDG 11, which focuses on making cities and human settlements inclusive, safe, resilient, and sustainable. Specifically, we're exploring SDG 11.6, which aims to reduce the adverse environmental impact of cities, particularly improving air quality. Before getting into any details, we want to point out why our project matters. Over 131 million Americans, which is about 39%, live in areas with unhealthy air from 2020 to 2022. Polluted air, especially in cities, increases the risk of asthma, lung damage, and heart disease. That's why reducing air pollution is critical, not just for the environment, but for public health and equity.
Now let's talk about the types of pollution that contaminate our world today. Particulate matter is the most common form of pollution on Earth. It is defined as a mixture of solid and liquid particles suspended in air and consists of dust, pollen, soot, and various other substances. The type of particulate matter we will be focusing on is PM 2.5, which is especially dangerous since it can cause respiratory issues and is commonly found in urban and industrial areas. Next, we have nitrogen oxides. These gases, like nitrogen dioxide, are emitted from vehicles and industrial processes. They are widespread in areas with high vehicular traffic and industrial activity, and significantly contribute to air pollution. They can cause respiratory irritation, damage the lungs, and further cause the formation of ozone. Lastly, we have ozone. Ozone is a secondary pollutant formed when sunlight reacts with nitrogen oxides and volatile organic compounds in the atmosphere. It's also commonly found in urban environments with heavy traffic and industrial emissions. While ozone, high in the atmosphere, protects us from harmful UV rays, ground level ozone is a harmful air pollutant since it can irritate the respiratory systems, worsen asthma, and decrease lung function, especially in vulnerable populations.
Now that we have basic information about forms of pollution in air, we can shift our focus to how pollution is affecting the real world around us. Our solution is designed to focus on a specific area in the United States first, and can be expanded to other areas if needed. So, to better understand where to target, we did some research on the rate of air pollution in each state. The dark blue areas indicate the states exposed to the most PM 2.5, while the light blue represents those that are exposed to the least PM 2.5. As we saw in the last slide, the states that have the highest levels of PM 2.5 are California, Idaho, Pennsylvania, Indiana, and Illinois. Here's more data on the pollution rate in different states. We can see that most cities that are on this list are in California. So for this project, we'll be focusing on Los Angeles, one of the most polluted and populated cities of California.
Now, let's talk about the solution that we, Future Skyline, created. Introducing the Vapor Filtration Sprinklers. VAPOR stands for Vapor Air Purification on Response, and that's exactly what these sprinklers do. Using a combination of data from air quality sensors and satellites, which we will discuss in detail later, these sprinklers will release various substances such as pure water vapor and chemical neutralizers in order to combat the most common types of pollution that we talked about earlier. These sprinklers, powered by solar panels, will be installed on traffic lights, in schools, and in factories, as well as other places where the most pollution is produced. As mentioned earlier, the sprinkler will include an air quality sensor that will detect rises in the AQI, or air quality index levels of the air at any given time. If the sensor detects an AQI of 101 to 150, which, as seen in the table, is potentially harmful for sensitive groups, it will activate the sprinkler. Using satellite data, we can detect rising concentrations of air pollutants across a city on an hourly basis, as well as predict where pollution will build up next using AI modeling and weather or wind flow data. The satellites, together with the air quality sensors, will allow for the sprinklers to operate with great precision, minimizing potential waste. Depending on the type of pollution most present in the air, the sprinklers will release pure water mist for high levels of PM 2.5, ionic sprays for NO2, and potassium iodide with water, which is a chemical neutralizer, for O3. Here is a potential design of what the vapor sprinkler might look like.
Finally, to prove that the chemicals that the sprinkler releases can actually decrease or cancel out pollution in the air, let's take a look at the chemistry behind our solution. The first substance that is in the sprinkler is pure water vapor. It is designed to remove PM 2.5 particles. While water mist doesn't chemically react with PM 2.5, it removes it through a physical process. When mist is sprayed into polluted air, the tiny water droplets collide with PM 2.5 particles and trap them. As the droplets become heavier, they fall to the ground, taking the harmful particles with them. This process helps clean the air, similar to how rain naturally washes out pollution. The second substance is ionic spray, and it is designed to neutralize nitrogen dioxide particles. The spray releases hydroxide ions, which react with NO2 to form less harmful nitrite, nitrate, and water. This reduces the toxic and acidic effects of NO2 in the air, improving air quality through a targeted chemical reaction. Lastly, we have chemical neutralizers, like potassium iodide, that can react with ozone to break it down. In the presence of water, Ki reacts with ozone to produce iodine, potassium hydroxide, and oxygen. This process reduces harmful ozone levels in the air and helps improve air quality, especially in enclosed or high exposure area. The balanced chemical equations for each substance are shown below.
To conclude, although we continue to see new technological advancements every year in an effort to reduce waste and pollution, we are still far from becoming the ideal green societies. This is why we believe that our solution has the potential to make a real impact in the world, and we hope that it may provide inspiration for those currently leading the efforts against the pollution crisis. Thank you.